Look at this structure. From a distance, it looks like a glitch in reality. A 100-story monolith of white steel and gold-tinted glass that shouldn't be standing, yet it dominates the horizon. This is the Oceanus Tower, a $2 billion bet against the laws of gravity. Its most defining feature isn't its height, but the fact that the top 30 floors are hanging 50 meters out over the open ocean with absolutely no visible support pillars. This is the world's most ambitious cantilever, an engineering feat so complex that many believed it was physically impossible to build. To understand how 90,000 tons of steel can float in midair, we have to look past the luxury glass and into the mechanical heart of a structural miracle. The secret begins with the central core. Most skyscrapers rely on a wide base to distribute weight. Oceanus does the opposite. It uses a high-density, ultra-reinforced concrete spine that acts as a vertical anchor. But even a spine of reinforced steel can't stop 30 floors from snapping off like a dry branch under the weight of gravity. That's where the X-ray vision comes in. If we peel back the gold-tinted skin, we see a massive internal skeleton of V-shaped steel trusses. These aren't just for show. They are designed to redirect the downward force of the cantilever back into the main vertical core. It's a constant tug-of-war where the building is essentially holding itself up by its own bootstraps. On the ground, the logistics are even more staggering. We are looking at 10-meter-thick white steel support columns that are driven so deep into the seabed they reach bedrock that hasn't seen light in millions of years. Look at the base of the cantilever arm. Those aren't just decorative panels. Those are massive hydraulic pistons designed to micro-adjust the tension of the building in real time. Every second, thousands of sensors feed data into an AI that manages the pivot joint. This joint is the single most critical point of the entire $2 billion project. It consists of 5-meter-wide steel bolts, each forged in a specialized industrial plant that usually manufactures components for nuclear submarines. If you stand on the edge of the 70th floor, the sensation is one of pure vertigo. Looking straight down, there is nothing but 300 meters of empty air between you and the churning ocean waves. The building casts a shadow on the water that moves like a sundial for the city. But while you're enjoying the view, the engineering is working overtime. The pivot joint is under more pressure than the hull of a deep-sea submersible. We use digital stress heat maps to monitor the load distribution. When the red glow on the sensor hits a certain threshold, a secondary counterweight system triggers, shifting the center of gravity in milliseconds to prevent structural fatigue. Inside the floating section, you wouldn't know you're hanging over an abyss. The luxury 5-star hotel lobby feels as stable as a mountain, despite the fact that it is technically a bridge to nowhere. The floor-to-ceiling glass is 3-layered and gold-reinforced to handle the extreme atmospheric pressure at this altitude. Guests walk across transparent glass floors that reveal the sea below, a psychological test as much as a luxury feature. But the real challenge isn't just gravity, it's the wind. At this height, the wind doesn't just blow, it attacks. The Oceanus Tower is designed to flex. During high-wind simulations, the top of the building can sway by 10 centimeters. While that sounds terrifying, it's actually what keeps it from snapping. Aerodynamic winglets on the corners of the skyscraper adjust their angle rhythmically, like the feathers on a bird's wing, to break up the wind vortexes that would otherwise cause the tower to oscillate. This is aeroelasticity taken to its absolute limit. If the building were rigid, the wind would shatter it. Because it is flexible, it survives. Nightfall transforms the tower into a high-tech sentinel. We use specialized drones equipped with LED searchlights to perform automated inspections of every steel joint. These drones look for microscopic cracks that could indicate stress. Every weld, every bolt, and every plate of the Oceanus Atlas blue steel must be perfect. Below the waterline, the foundation piles are monitored by bioluminescent sensors. If the seabed shifts even a millimeter, the building's base isolators compensate. This is smart architecture in its purest form, a living, breathing machine that houses thousands of people. The internal systems are a masterpiece of industrial design. We are talking about rows of 15-meter-tall hydraulic pistons that act as the building's shock absorbers. In the steel forge, where the V-Trusses were created, the molten metal was poured at temperatures exceeding 3,000 degrees to ensure no air bubbles could weaken the structure. This is precision at a scale that is hard to comprehend. The gold glass itself is smart. It tints automatically as the sun hits it, reducing the cooling load and saving millions in energy costs. It's not just about looking expensive. It's about being the most efficient square foot on the planet. One of the most impressive secrets is the tuned mass damper. Deep inside a massive mechanical room at the back of the tower hangs a 600-ton lead pendulum. When the wind pushes the building left, the pendulum swings right. It's a silent, heavy guardian that cancels out the energy of the wind. Without this damper, the guests in the luxury suites would feel seasick within minutes. Instead, they feel nothing but the prestige of living in a $2 billion miracle. The elevators are no different. Magnetic rails glowing with purple light shoot pods up 100 stories at speeds that would make a sports car jealous. In the final analysis, the Oceanus Tower represents a shift in how we think about space. We no longer have to build on the ground, we can build in the air. We can extend our cities over the oceans and into the clouds. The $2 billion spent wasn't just on steel and glass. It was spent on the knowledge of how to conquer gravity itself. As the camera flies upward past the cantilever and into the white clouds, we are left with a single realization. The horizon is no longer the limit. The Oceanus Tower is just the beginning of a new era of architectural chaos and brilliance.